Unit 8, Part 6. I just introduced you to proof bits in Part 5, screenshotting the text, and I will now do proof bit 3 for you and proof bit 11 over there. As I was stressing, right, the really important thing to grasp is that the proof bits are presented in terms of P's and Q's, right, sentential variables, but what you need to master, right, you need to master all these proof bits. You really need to know for each proof bit, each premise to conclusion path, that there is such a path, right, that you can go from, say, premises of these two forms to a conclusion of that form, or from that if you need to know that if a negated conjunction is what you need, you can get there from the negation of one of the conjuncts. But when are you going to be using these proof bits, right? You need to understand them in their full formality or generality, because when you do them in exams, it won't be in terms of P's and Q's, and it won't be these simple forms, or at least it will be the simple forms, but those simple forms present in not simple, but often complex examples, like this, right? So, you know, if you'll be presented with things like this, where it's the P and the Q are not just simple sentential variables, but rather themselves complex, ugly formulas, like, for example, B biconditional D and D hook E, right? But you need to look at this, and you need to see in a particular problem like that, you need to see that a particular problem like this calls for the application of this proof bit, okay? Let me do the proof bit first. So again, the things you need to know, first of all, that the path is available is available to the negation of a conjunction from the negation of one of the conjuncts, and again, I'm saying it that way, saying it in its formality and generality, such that you can recognize that what this is telling you is that there is a path to any negation of a conjunction from the negation of one of the conjuncts. Okay. You need to know that the path is available for all of the proof bits, and then you need to know how to actually perform the proof. That bit's sort of easy. You can work it out. Although, let me stress what isn't very much stressed in the text. I pretty much think all these proof bits backwards in terms of how the proof bit goes, right? So, of course, you just have the page with the completed proof, and it looks like the formulas are busted out from top to bottom. I actually sort of pull them out from bottom to top, right? That'll be clear, especially when I do proof bit 11, right? I wouldn't know what exactly to add. You'll see if you read through the text that most of these proof bits involve adding something, that is, using the rule of addition, ADD. Shorthand is the abbreviation for addition. You add, right, addition is the rule. Given a formula, you're allowed to infer the disjunction of that formula in something else. So we use that a lot in these proof bits, but what you add and when you do a double negation and that kind of thing, it's much harder to anticipate thinking it top down, what you do, what exactly moves you need to make and in which order. It's easier the way I figure it out each time is working backwards, right? I know that I need this, okay, what's this equivalent to? Okay, so we'll do this one. If this was a premise, what would I ask you to do? Right? This is a negated conjunction, you'd be in the habit of using De Morgan's and writing down the equivalent formula, not P or Q. Shouldn't have had this on, but right, I've thought De Morgan's this way, right? I've thought it this way. In some sense, it's my knowledge of the proof bit is involved in that I'm thinking, oh yeah, all these proof bits involve adding something somewhere. The result of doing De Morgan's, as it were, thinking it this way, is a disjunction, right? That is, I can get a formula equivalent to this formula that is in the form of a disjunction, and that, because it's in the form of a disjunction, that is one of the two sides, that's in the form of one of the two sides of addition. Sorry, addition is not a replacement rule. It's in the form of the conclusion of addition. Addition is a rule of inference, right? Not a replacement rule, but this is in the form of a conclusion of addition. Namely, it is a disjunction, which is what the form of the conclusion of addition is, right? So I can see now what it is I need to add, right? That's it. So right, and then that's the whole proof. 1, 2, 3, right? This is premise, and then I add to this. Notice De Morgan's, right? I thought De Morgan's this way. I thought it backwards. That was my conclusion. And I thought, what's this equivalent to? It's equivalent to this by De Morgan's, but don't make the mistake of writing De Morgan's here, right? Again, it's when you write this down on the second last line, you're still, what you've determined is that, what you've discovered is that this formula is what you need, right? This is the one you need. You don't have it. When you write that down, right, you can put a question mark here. It's a question mark how I derive that. You have to figure out how you get that from the premises. And we just saw that all we do is add. But in the actual proof, right, De Morgan is the justification for actually going from this to this, right? So I thought De Morgan going that way, but in the actual justification, it's the move from that to that is De Morgan. Okay, so that's the proof bit, but this is the kind of situation now, this is the important part. This is the kind of situation you'll need to apply it. You'll need to be able to recognize when you're presented with a proof like this, a problem like this, that you need to bring out this proof bit. This is why I love section 4 so much, because several of those problems require, at a certain stage of figuring things out and working backwards, you to have mastery of this section of the course, of the Unit 8 rules, and to be a master at being able to do proofs. Try those exercises in Unit 4, the ones Klenk works through. But if you have mastery, you'll have a moment where, working backwards, you'll figure out what you need. In a couple of cases, it's going to be you need a negated conjunction, and then you have to have the aha moment. That you can get there because you have the negation of one of the conjuncts, right? So something like this, right? Where you would say, right, working backwards, how would you think? And this is only 2 premises, right? So this one's going to be pretty easy compared to other ones where there's a bunch of other premises and other things you need to look at and ignore when appropriate, right? But here you think, okay, the usual strategy, which you're familiar with, I'm after the conclusion F. Where does F appear plus or minus negation amongst the premises? It appears as the consequent of this conditional, right? And this is a conditional, so be attentive to the form of this thing. What is the form of 2, right? Is it a negation? No, it is not a negation. It's a conditional. It's a conditional, right? Use the right-hand rule here to see what is negated. Open bracket, uh-oh, I don't have a legal formula until I close both brackets, right? What's negated? The first legal formula you come across when you move your hand to the right. 2 open brackets, B hook D, close 1 bracket. That's not a legal formula because I had 2 open brackets. Okay, dot, open bracket, I'm going to close 2 brackets again. D hook E, not yet, because this closes this bracket, boom. Okay, now I've closed that bracket. Finally, I have a legal formula, so it's that which is negated. The scope of the negation is all of that. And what is this formula? It is a conditional where that is the antecedent. Sorry, where this whole thing, including the negation, is the antecedent, and that's the consequent. F is the consequent. Right. So the last step in the order of construction of this formula was taking this whole thing, the negation of this conjunction, and making a conditional out of it by adding F as the consequent. Okay, so you need to see that form, and then you think, okay, F is the consequent of a conditional. How do I derive consequence of conditionals. I need to use the rule of modus ponens. What formula do I need to use modus ponens here? I need the antecedent of the conditional, right? So what do I need? I need not brackets B by conditional D, and so I need the negation of the conjunction of B by conditional D and D hook E, right? Now you have to think it formally. It's actually absolutely crucial. What have I got? How the hell am I going to get there, right? You need to see at this stage that your task is to get a negated conjunction from what? All I have is the negation of one of the conjuncts, right? Aha, this is where you have to have the aha moment, right? There is a proof bit. Oh, I remember. There's a proof bit. There is a path from the negation of one of the conjuncts to the negation of the conjunction. So, right, how do I get to it? How do I get to? That's what I need. Right. Once I have this, I'll do modus ponens on 2 and whatever step that is. But how do I get this? Okay, it's, right, what's this equivalent to? Let me do, now thinking backwards. So now this is equivalent to, this is of the form, not P and Q. And now I'm going to think it backwards, just like that. So you have to be very good, as I've stressed, at applying De Morgan's to complex situations. Again, I'm thinking backwards, so it's not B by conditional D, or not brackets D hook E, right? That's the equivalent of that by De Morgan's. Again, the justification will go this way. That is, when I have that, I'll be justifying this from De Morgan's, and then I'll be out of modus ponens. So now, how do I get this? Okay, now I know what I need to add. I can get this from that by addition, right? So 1, 2, 3, 4, 5, right? Okay, so 1 addition, right? See how I figured that out? If you hadn't done it that way, you would have never you'd never figure out what formula exactly you need to add, right? But this is a completely legitimate move of what form? P equals not brackets A by conditional B, to P or Q. Q is not brackets D hook E, right? This is the form P, from P to P or Q. But what have I added? This very specific formula. I never would have known to add that specific formula unless I figured it out and thought it through the way I did so there. Okay?